The partial reconfiguration flow, or PR, has been used since the advent on the market of the Xilinx Virtex 4 devices. In the PR flow, the requirements of a column-wise reconfiguration are removed, which means that a two-dimensional shaped modus can be finally defined. Moreover, it is no longer needed to constrain the static design, which means that we can also get rid of the mass macro instantiations. All these benefits have been introduced into a design flow which is now extending the module-based one by going through 5 phases: HDL description and synthesis, define design constraint, implement base design, implement PRM design, merge phase, PRM plus base design. The HDL description and synthesis phase has remained the same as it was in the module-based flow. The define design constraint phase is somehow the new version of the previous initial budgeting phase. During this phase, we do have to identify all the design constraints. As an example, during this phase we have to identify all the area constraints for each reconfigurable region. The implement base design and the implement PRM design are two similar phases. In fact, they are both implementing the same action but on different elements. This figure is presenting you the results of these two phases. They are both implementation phases, which means that we are going to go through the technology mapping and the place and route phases with both of them. But while the PRM design one is working on the implementation of each PRM, where a PRM in the Xilinx terminology is a partial reconfigurable module, the same as our reconfigurable functional unit, the base design is working on all the elements of the design that are not reconfigurable. This is quite important, because we have to go first through the implementation-based design phase to place and route all the elements in the design, being aware, because of the constraints identified in the define design constraint phase, of all the reconfigurable region placements. This information is useful because in having this, the implement-based design phase can try to minimize, wherever possible, the usage of resources in the reconfigurable regions by elements of the design that are not belonging to the reconfigurable functional units implemented in the reconfigurable regions. Once the base design, which can be seen as the static portion of our system, have been implemented, we can now proceed with the implementation of each reconfigurable functional unit. We are going to do this by passing the information on resources that are no longer available because of the implementation of the base design to the place and route phase of each reconfigurable functional unit. By doing this, we are going to guarantee that the resources used to implement the base design won't be involved in any reconfiguration process that may occur at runtime. The final phase is the merge phase, where the partial reconfigurable modules will be combined with the base design, and this is exactly what you can see in the figure. Now, what it is interesting to be noticed is that we started with the idea of having 3 different design flows to support partial reconfiguration: difference-based, module-based, PR. That was as you know, the shortened version of partial reconfiguration. But if we are going to look closer at them, we can now see that we have just one flow evolving over time. And by doing this, we can also say that the theoretical work that we did was not meant to focus on making you proficient in a single design flow, but I was willing of identifying the main constituting phases of a flow for implementing partial reconfigurable system, which means that even if in the future these design flows are going to change, you'll still have all the necessary background knowledge to properly understand them. Let us better see the connections in between the 3 design flows. The modular approach presented in the module-based flow is basically the same flow with some, let's say, technical adjustments we have in the partial reconfiguration. Not only, in both these flows, we have a sort of a final assembly phase, which is used to create the starting configuration bitstream plus a set of partial reconfiguration bitstreams. Now, how these partial reconfiguration bitstreams are created? Easy to see. By identifying the differences in between what is a configuration of the system implemented on the FPGA at a certain time and the configuration of the system that we are interested in having after having reconfigured it. This is again bringing us to the point that in having the tools to implement the design is necessary, but not enough. We do have to have our reconfigurable friendly ecosystem, where, as in this case, we're going to have a scheduling policy that will mimic the runtime conditions to help us in identifying all the possible interesting couples of starting and ending configurations used to generate the necessary partial reconfiguration bitstreams.